We are looking at notebook page 248, and we're going to start looking at the significant figure rules when we multiply and divide answers. So we're not changing how we do the math. Do the math in the calculator, but it's how we figure out how many digits to keep in the final significant figure answer. So put the numbers in your calculator, get your calculated answer. And then the final answer is rounded to the lower number of significant figures. So the lowest number of significant figures. So take a look. In your calculator, if you multiply 0.201 times 3.3901, you get a calculated answer of 0.681401. That's the calculator answer. Now to go from this calculator answer to the best final answer, which contains the correct number of significant figures, we go back to our measurements. Okay, the measurement of 0.201 has 3 sig figs, whereas the other measurement has a total of 1, 2, 3, 4, 5 significant figures. So our final answer can only be as precise and accurate as our measurement with the least number of significant figures. So in this case, okay, we can only keep 3 of the calculator answers. So remember, leading zeros are never significant. So we start on the left with our first non-zero digit, and then keep 2 more to the right of it. So these are the 3 digits I'm going to keep. And then I look at any digits further to the right. Do they allow the 1 to be rounded up to a 2? No. So my final sig fig answer, I can keep the leading zero there, 0.681. Just remember, whatever math we do with the measurements, we have to do with the units. So I have centimeters times centimeters, which makes it 0.681 centimeters squared. Now, take a look at the next example. 100.1 divided by 2002. And when you put this in the calculator, your calculator answer is going to be 0.05. That's what the calculator is going to show. Now we need to figure out, when we express our final answer, how many sig figs must it contain. So like before, go back to the 2 measurements that were used in the math. So 100.1 has 4 sig figs. 2002, because in both these numbers the zeros are trapped, this also has 4. So that means that when we record our final answer, it must have 4 significant figures. But when I look at this, leading zero, here is my first non-zero digit, and the calculator does not supply any other digits to the right of it. But I have to have 4 digits, so I have to be smarter than the calculator. So I am going to keep those placeholders, and I have my only significant digit that the calculator has, so I have 1. So now to get my sig figs, I'm going to add in 3 more zeros. So my leading zeros are not significant. Here's my first non-zero digit. And these trailing zeros, because of that decimal point, are significant. And this is my 4th and final sig fig. Now, unit-wise, so don't forget, no naked numbers, it's grams divided by milliliters. Neither unit reduces, so we have a fractional relationship at the end, grams per milliliter. Last example here. So now it's a little bit more complicated because we have 2.56 times 100.1, and then that product is divided by 0.01. And when you put this into the calculator, you get an answer of 2, 5, 6, 2, 5.6. So if I read this, it's 25,625.6. How many sig figs are we allowed to keep? So we have to go back and look at the measurements. 2.56 has 3 sig figs. 100.1 has 4. And now I have to look at this number. The number that's in seconds, it has 2 leading zeros, not significant. Here's my first non-zero digit, and those trailing zeros, because of that decimal point, are significant. So this contains 3 significant digits. So this final calculated answer, the lowest number is 3. I'm only allowed to keep 3 of the calculator digits. So here we go, 256. So when I go to write down my answer, I write down 256, but this is 25,625.6. So if you think about it as money, $25,625.60 versus $256, those values are nowhere similar. So that means to get this to a similar value, I need to add those placeholder zeros. So these placeholder zeros, they're placeholders. They are not significant, but they make the value, or they help maintain the value. So 25,600 is a much more similar value to $25,625. Now, no naked numbers, units. I have meter times meter divided by seconds. So my unit, meter times meter divided by seconds. My 2 meters are upstairs, like x times x. So x times x, meters times meters, the unit becomes squared. There are no seconds upstairs, so it stays down below. So we have 25 meters squared per second. So now you try these 3 you-do problems. So simply first put the math in your calculator and write down all the digits from your calculator. Then go back and count how many significant digits in each of those measurements. And the lower number of sig figs, that's the number of digits you're allowed to keep from your calculated answer. Just remember, you might need to add leading or trailing zeros in order to maintain significant, or to maintain value.